Find the peak flow rate, Q sub p, in cubic feet per second. In this problem, 3 watersheds drain to a common outlet, and the runoff is conveyed off-site by a drain pipe. The area, runoff coefficient, and time of concentration for each watershed are provided in the data table. The intensity curve for the given storm is also provided. The peak flow rate, Q sub p, in cubic feet per second equals 1.008 times the runoff coefficient, C, times the intensity, I, in inches per hour, times the shed area, A, in acres. Considering the precision of the factors, the 1.008 term is usually rounded to 1, and the equation becomes Q sub p equals C times I times A. Let's begin with the area. The total area equals the sum of the watershed areas A, B, and C. After plugging in the values from the data table, we find the total area equals 20 acres. Next, we'll solve for the runoff coefficient, C, which equals the average of the runoff coefficients from the contributing watersheds weighted by the area. Plugging in the values for C and A, the weighted C value equals 0.563. The last variable to solve for is I, the intensity. The storm intensity is a function of the time of concentration, T sub C. The intensity decreases asymptotically with T sub C. For the given equation, we should use the maximum T sub C value for all contributing watersheds. This means runoff from all areas of the watersheds will contribute to the peak flow rate, Q sub p. The time of concentration for this problem is 45 minutes. Plugging 45 minutes into the IDF curve, the storm intensity equals 2.308 inches per hour. Returning to the rational equation, we can compute the peak flow rate by plugging in our values for C, I, and A. And the peak flow rate equals 25.99 cubic feet per second. Looking over the possible solutions, the answer is D.